So yesterday we reviewed our operations with our polynomials, and we went over more of the division of polynomials. It's not something we're going to stress or push, but it is something that's a handy thing to know, because in this next section we're going to look at reversing our multiplications. For example, one of the multiplications we did might have looked something like this. 7x to the third y times 8y squared minus 5x. And when we multiplied that out, of course, we distributed. 7x to the third y times 8y squared is going to give us what? 56x to the third y to the third. Good. We multiply the count. 7 times 8 is 56, and then we multiply each name separately. X to the third has nothing to multiply, so it stays x to the third. Y times y squared is y to the third. Then we do the 7x to the third y times the negative 5x, gives us negative what?
35x to the fourth y.
There we go, 35x to the fourth y. Perfect. What's that? No, so what we want to do today is we want to look at reversing that process. We want to look at something called factoring. And for factoring, we're going to break it down into smaller components that would multiply up to make it. If you recall from numbers, if I asked you to factor 15, what you did was you broke it down into 3 times 5. We had other values that if I asked you to factor something like 12, it could be split down into more than just 2 pieces. 12, you could go as 3 times 4. Well, the 4 is prime, but the 4 can split into 2 times 2. So 12 factors into 2 times 2 times 3. Well, the same type of thing here. I want to break that into pieces that can multiply together to give us this result. Well, we just multiplied this together, so we know those are the pieces. But how can we reverse it to get it back to that? Well, the first thing we look for, just like we looked for over here, is common factors. Only we want to have the greatest common factor. From now on, it'll be referred to as simply the GCF. That greatest common factor, remember, is the largest number that divides into both of those terms, into both of those digits. So we need to look at the numbers, the 56 and the 35. 7 is the largest number that goes into both of those. Perfect. Then we also need to look at the variables. We got x to the third, y to the third, and then we got x to the fourth y. Greatest common factor for variables is the smallest power of each variable. So we have the 7 for the numbers for the 56 and 35. For x, what's our greatest common factor going to be? X to the third and x to the fourth. The smaller one is x to the third. Good. How about for y? Just y. Good. We've got y to the third, and then we've got just y, or y to the 1. That y to the 1 is the smallest, so just y. Now, when we were working with our numbers, we found the first factor. We found that 15 was divisible by 3, so that 3 is a factor of 15. To find the other number, we did 15 divided by 3 gave us that 5. We do the same thing over here. To find the other number here, we take that and we divide it by that factor, that greatest common factor of 7 x to the third y. So what is 56 x to the third y to the third divided by 7 x to the third y? 56 divided by...
8y squared minus
Perfect.
5
Don't get too far ahead of me here.
x.
So just for the 56 x to the third y to the third, 56 divided by 7 is 8. X to the third divided by x to the third cancels out. Y to the third divided by y. Remember, think of that as y to the 1. 3 minus 1 is 2, so we do get y squared. Then we'll move over to the next piece, the negative 35 x to the fourth y divided by the 7x to the third y. What do we get there?
Is minus 5x.
Perfect, minus 5x. Negative 35 divided by 7 is negative 5. X to the fourth divided by x to the third. 4 minus 3 is 1, so x to the 1, or just x. And y divided by y divides out. So there we have factored that back out. Now notice, that's what we had started with before. Most of the time, well, all of the time from here on out, we won't be multiplying it out first. We'll be starting with that bigger expression and factoring it down. So we might start with something like this. 48 x to the fifth y to the third plus 64 x to the third y to the fourth. So we have our numbers 48 and 64. We need to find the greatest common factor. If we are stumped on finding that greatest common factor, what we can do is prime factor each number. What would that mean? Well, that would mean doing that factor tree. Remember 48? Well, 6 goes into 48. 48 divided by 6 would be 8. 6 splits into 2 times 3. 8 splits into 2 times 4. 4 splits into 2 times 2. So 48 can be prime factored into 2 times 2 times 2 times 2 times 3. 64 can actually be prime factored into 6 2s. Our greatest common factor is a combination of all common factors. So what do these have in common? They have a 2. They have another 2. They have a third 2. And they have a fourth 2 in common. Now the rest of them are all different. So our GCF, our greatest common factor for 48 and 64, is found by multiplying 2 times 2 times 2 times 2, which is 16. So 16 is the number that divides into both 48 and 64, the largest number that divides into both of them. Now for the variables, we do the same thing. It is the smallest power for each variable. So for x, what's going to go into our greatest common factor? X to the third, perfect. We have x to the fifth and x to the third. X to the third is the smaller power. How about for y? Also y to the third. We have y to the third and y to the fourth. Y to the third is the smaller power. So to find the other factor, we're going to divide that by 16x to the third y to the third. So 48x to the fifth y to the third divided by 16x to the third y to the third. What's it leave us with?
X squared.
48 divided by 16 is 3. X to the fifth divided by x to the third is x squared, and y to the third divided by y to the third cancels out. Now we move over. 64 x to the third y to the fourth divided by the 16 x to the third y to the third. Four y, perfect. 64 divided by 16 is 4. X to the third divided by x to the third divides out, and the y to the fourth divided by y to the third is just y. And that's it. We can look inside this parentheses to be sure there are no more common factors, so we have divided that out as far as we can go. I'm going to have you try one. (28x to the fifth y) minus 70 x squared y squared z. So in your notes, I'm going to have you find the greatest common factor and divide it out to factor that. So for 28 and 70, what is the largest number that divides into those? 7 will divide in, but there's a larger one. 14, good. If we have to prime factor them, 28 factors into 2 times 2 times 7. 70 factors into 2 times 5 times 7. They both have a 2 and a 7 in common, so 2 times 7 is 14. Now, since you said 7, once we're done with this, I'll go back and I'll show you what would happen if you use 7. You wouldn't be dead in the water. There's still a way to recover and get the right answer. How about for x? What power of x? X squared. How about y? Just y. And then z isn't part of it. Z only appears here. There's no z here. So I can think of this as being z to the 0, or just, 1. So it doesn't have to appear. So z will not be in our greatest common factor. Now we have to divide out that 14x squared y. So what is 28x to the fifth y divided by 14x squared y? 2x to the third, good. How about 70x squared y squared z divided by 14x squared y? -5, the x squareds divide out, so yes, it's y and z. So there it is. Now you had brought up 7 as being a common factor. Just like when we were reducing fractions, I said you didn't have to find the largest number that divides into both of them. You can do that here. That applies here as well. Let's say you just used 7x squared y as your greatest common factor, and you divided that out. Well, 28x to the fifth y divided by 7x squared y is going to be 4x to the third. -70 x squared y squared z divided by the 7x squared y is going to be a -10 yz. When I look at what's inside the parentheses here, I see that both those still have a common factor of 2. So I'm going to divide out that 2. Well, when I divide out that 2, I have to put it somewhere. I'm going to combine it with the 7x squared y. So it becomes 14x squared y. Dividing out the 2 here, 4 divided by 2 gives me the 2x to the third. -10yz divided by 2 gives me -5yz. So we can still end up in the place we need to go. It's just an extra step. The little bit of a tricky part is whatever we divide out here, we have to multiply that back into our greatest common factor, or common factor, so that it stays in there in the problem somewhere. We're just transferring it. That's just like for 24. We can express that as 4 times 6. But if I wanted to change that, if I wanted to divide that 6 by 2, that becomes a 3. I would have to multiply the 8 by 2, or the 4 by 2 to get 8. So 24 can either be 4 times 6 or 8 times 3. I'm just transferring it from one of the factors to the other. We can have greatest common factors with more than 2 digits. We might have something like 75, x to the 5th, y squared, z to the 3rd, minus 45, x to the 3rd, y to the 3rd, z, plus 30, x, y to the 5th, z squared. When I look at this, what number is my greatest common factor for 75, 45, and 30? 15, very good. How about then for x? Just x. I got x to the 5th, x to the 3rd, and then just x. So x is my greatest common factor for that. How about y? Y squared, good. And for z? Just z. So now I have to divide out that 15x y squared z. So 75 divided by 15, what's that going to give us? 5, and then what's up with the variables? Careful. The y divides out, but we still have z squared. Good. How about the negative 45 divided by the 15? Minus 3. Perfect. Negative 3x squared y. And then the 30 divided by the 15. Perfect. Plus 2 y to the 3rd z. Any questions there? Okay, so when we're asked to factor, the first thing we will always look for is a greatest common factor. And the greatest common factor doesn't depend on how many terms there are. We did some with 2 terms up here. We did an example here with 3 terms. And we could have 4 terms. We might have, let's see here, 36 x to the 5th, y squared minus 24 x to the 4th, y to the 4th, plus 48 x to the 3rd, y to the 6th, minus 60 x squared, y to the 8th. Now it's a little bit more difficult because we have more terms, but it's still looking at what is the greatest common factor for 36, 24, and 48, and 60. 12 should work. How about x for the x's here? X squared. And for the y's? Y squared. Good. So now we have to divide that out, the 12x squared y squared, to get what is remaining after removing that greatest common factor. What is the 36x to the 5th y squared divided by our 12x squared y squared? 3x to the 3rd. There we go. How about our negative 24x to the 4th y to the 4th divided by 12x squared y squared? Perfect. Negative 2x squared y squared. 48x to the 3rd y to the 6th divided by 12x squared y squared. Perfect. 4xy to the 4th. And how about the negative 60x squared y to the 8th divided by the 12x squared y squared? Perfect. Negative 5y to the 6th. And there it is. That's it. So even with 4 terms, we can still look for a greatest common factor. Well, what if there isn't a greatest common factor that goes through the whole thing? What if we have, let's see here. Something like this. There are 4 terms here. Is there a greatest common factor that can come out of this? Well, I get 35, 14, 10, and 4. Is there any number that divides into all of those, all 4 of those? Well, let's factor them out if we have to. 35 factors into 5 times 7. 14 factors into 2 times 7. So far we were promising we got the 7. 10, however, is 2 times 5. There's no number that's in all 3 of those, is there? 2 of them have a 7, 2 of them have a 5, and 2 of them have a 2, but none of them have the same number in all 3. And of course, 4 is 2 times 2. So there is no greatest common factor for the numbers. How about the variable? No, this term has no variable in it. So the variable cannot be a greatest common factor for all 3 of them. In this case, what we would do is we would make sure they are in descending order, which they are. Remember, descending order means we go from the powers of largest to smallest. And we try to find combinations of 2 terms that have common factors to see what happens when we do that. If we look at these first 2 terms here, 35x to the 3rd and negative 14x squared, we see that both of those, if I just split it right here, both of those can be divided by 7x squared, correct? So let's divide them by 7x squared. What would we get left over? 35x to the cube divided... Oops, what is that? 5x minus 2, very good. 35 divided by 7 is 5. X to the 3rd divided by x squared is just x. The negative 14x squared divided by 7x squared is negative 2. Now let's look on the other side over here. 10x and negative 4. What can both of those have as a common factor? Positive 2. So if I divide out that 2, what is left there? 5x minus 2. So I grouped them. This is called grouping. I grouped them into pairs of terms, and I found the largest common factor for each pair. And what I'm trying to do is get the same value left over after I factor out those factors. And here I did. I have 5x minus 2 inside the parentheses in both groupings. So what that means is I can divide out that 5x minus 2 as a common factor. So what's left over is 5x minus 2 times, if I divide it out here, I'm left with just 7x squared. If I divide it out here, I'm just left with the positive 2. So I get 5x minus 2 times 7x squared plus 2. Let's verify that that is a factoring of what we started with here. If I do my FOIL, 5x times 7x squared is 35x to the third. We do the outside, 5x times 2. Positive 10x. Now I'm going to put it over here because I know that I'm coming up with a x squared here. Negative 2 times 7x squared. Negative 14x squared. And negative 2 times 2? Negative 4. If I compare that to what I started with, it is what I started with. So this here, 5x minus 2 times 7x squared plus 2 is a valid factoring for that polynomial. Well, let's look at another example. So when I look at this, is there any number, is there any common factor that goes into all four of those terms? No, there's not. The variable does not appear in every term, so that's not a common factor. We have 6, 10, 27, and 45. There is no number that divides into all four of those. So we're going to group it. And I'm going to split it up with the first two terms and then the last two terms. The first two terms, 6x to the third and 10x squared, what can I get for a common factor there? 2x squared. And if I divide that out, what's left over? 3x plus 5. Good. Now over here, I've got 27x, negative 27x minus 45. I have a common factor there of 9. So if I divide out the 9, what do I get? Negative 27x divided by 9 is negative 3x. Negative 45 divided by 9 is negative 5. Now you might be sitting there saying I did something wrong, and I did on purpose here. When I take out that 9, I get something here that is not the same as what I had in the first pairing. But we see that it's similar because it's just the opposite. They're negative terms instead of positive terms. Instead of positive 3x plus 5, we have negative 3x minus 5. So to make those the same, we can go back to this common factor and change it slightly. Instead of making it a positive 9, we can make it negative 9 that we divide out. So now negative 27x divided by negative 9, negative divided by negative is a positive. Negative 45 divided by negative 9, again, negative divided by negative is a positive 5. Now we have the same term left over in the parentheses, 3x plus 5. So what's that going to become?
3x plus 5 times 2x squared minus 9.
Perfect. 3x plus 5 times 2x squared minus 9. Any questions? So when we look at something like this, is there a common factor that can be divided out of every term there? No, there's not. So let's go to grouping. Let's look at the first two. What can I divide out of those first two? 4x squared, right? Perfect. So I'm going to divide out 4x squared. What am I left with?
Let's see, 7x plus 5.
7x plus 5. Good. Now in this second set, it looks like there's no common factor, but there's actually something that I have to take out of it to make it the same as what I have over here. What would that be?
Negative 1.
-1. Very good. I have to divide out -1. And of course, that would leave me with 7x plus 5. So now I do have that same amount left over inside the parentheses. I will now factor that out. So 7x plus 5, and of course, 4x squared minus 1. Now, I had told you before, we're used to being told that there's only one right way to do things in math, but that's generally not true. There are usually a couple of different ways you can do things. In many of these problems, we could switch the order of these terms and still factor correctly. What I mean is on this one, I could do this. I can take my 28x to the third, and I'm going to change it to minus 7x plus 20x squared minus 5. And now I'm going to group it this way. For my 28x to the third minus 7x, what can I take out of there as a greatest common factor? 7x, good. And when I divide by 7x, what's left? 4x squared minus 1, good. Over here, what can I take out of the 20x squared minus 5? Both of them. They divide by 5. And when I divide by 5, what's left? 20x squared divided by 5 is 4x squared minus 1. Perfect. And now we notice we have the same thing inside here, so we can factor that out. We got 4x squared minus 1, and what's left is the 7x plus 5. Notice it's the same factors. Not in the same order, but that doesn't matter. They're still the same factors. 3 times 5 is the same as 5 times 3. I'm going to have you try one of these in your notes. Give that one a shot in your notes. 6x to the third minus 21x squared plus 10x minus 35. So if I leave it just like this, I'll do the first two. What can I get for a common factor out of the first two? 3x squared. Good. And I divide out that 3x squared. What's left? 2x minus 7. Good. And the last two, what can I get for a common factor? Plus 5. Good. And I divide out 5. I'm left with 2x minus 7. Perfect. So now that I have the same value, the same expression in there, I can factor that out to get perfect. 2x minus 7 times 3x squared plus 5. So that was called grouping. So when we're asked to factor a polynomials, step one is to always look for a greatest common factor. If there is no greatest common factor, or once we take out the greatest common factor, we might examine what's left, we may then look for, the second step depends on how many terms there are. If there are 4 terms, we try that grouping, like we just did. If there are 3 terms, we're going to try this next procedure, which is reverse multiplication. Or sometimes called FOIL in reverse. So let's review FOIL for just a second. We'll make this easy on ourselves here for a minute. So if I try to multiply 2 binomials like this using FOIL, you recall we did the f was the first digits. X times x makes x squared. That's the first digits. We did the outside. X times 7 makes 7x. That's the O, the outside digits. We did the inside. 5 times x makes 5x. That's the I, the inside digits. Then we did the last. 5 times 7 makes 35. That was the L, or the last digits. So if I add these up, I get x squared plus 12x plus 35. I see that this first digit is found by multiplying the first digits of those 2 binomials. And this last digit is found by multiplying the last digits of those 2 binomials. This middle digit is the combination of the outside product and the inside product of those binomials. So if I'm asked to factor a polynomial, and I have something like this, a trinomial with no GCF, remember the first thing I always look for is a greatest common factor. There isn't one here. So the second thing is, if it's trinomial, 3 terms, I try to do reverse multiplication, or sometimes known as FOIL in reverse. So a trinomial typically will factor into 2 binomials. I know that these first 2 terms have to multiply to make that first term of the trinomial. What 2 things multiply to make x squared? X times x, correct? I know these last 2 terms multiply to make the last term of the binomial. To multiply to make 35, I have 2 choices. I have 5 times 7 or 1 times 35. How do I know which one's correct? Well, I pick one and I check it. Let's pick the 5 times 7. So positive 5, positive 7. Now the alternative there would have been negative 5 and negative 7. Why is that? Because that's a positive 35. Negative 5 times negative 7 would also multiply to make a positive 35. How do we check to see if that's correct? Well, we have to do outside and inside. On the outside, we've got x times 7. What's that give us? 7x. On the inside, we have 5 times x. What's that give us? 5x. If we add those up, we get 12x. And that's what we were looking for, is 12x. So this is the correct factorization. X plus 5 times x plus 7. So let's look at one where we didn't multiply it out to start with. So let's say we've got x squared plus 7x plus 12. First thing we should always look for, is there a common factor here at all? No, there's not. So there's 3 terms, so we're going to try to do reverse multiplication, or FOIL in reverse. We know that these first 2 terms have to multiply to make x squared. So what's that going to have to be? X times x. Very good. We know these last 2 terms have to multiply to make positive 12. We have some options. 1 times 12, 2 times 6, or 3 times 4. Let's try the 2 times 6. So let's test it. Remember, we have to do the outside and the inside. On the outside, we have x and 6 that multiply to make 6x. On the inside, we have 2 and x that multiplies to make 2x. If we multiply those together, we get 8x. Is that what we wanted? No, we wanted 7x. So the 2 and the 6 are not correct. Which ones are going to work? 3 and the 4. Good. So let's double check the outside. X and 4 make 4x. On the inside, we have 3 and x multiply to make 3x. Add those to get 7x, and that is what we wanted, 7x. So that factors to be x plus 3 times x plus 4. Any questions there? Okay, well, you've been hanging around me long enough for the semester to know it always gets worse. So we'll try something like this. Is there a common factor? No. So it's a trinomial, so we're going to try to break it into 2 binomials using that reverse multiplication, or FOIL in reverse. These first 2 digits are going to have to be x times x, because they have to make the x squared. These last 2 digits have to multiply to make 8. So it's 1 times 8 or 2 times 4. Now you're probably starting to see some of the combinations by now. Which pair is going to work? 1 and 8. Let's double check it. On the outside, we have x times 8 makes 8x. On the inside, 1 times x makes x, or 1x. We add that together. 8x plus 1x is 9x. So that is our correct factorization. X plus 1 times x plus 8. So you can see that these numbers multiply to make this one, but in these simple cases, they also add to make that one. What's different here? The negative. These were all positives. This one has a negative in it. It does complicate life a little bit for us. Is there a common factor? No. So we're going to try that reverse multiplication. First terms still have to be x times x. These last terms have to multiply to make negative 10. So that could be negative 1 times 10, or it could be 1 times negative 10. Could be negative 2 times 5, or 2 times negative 5. Let's try the bottom one, positive 2 times negative 5, and negative 5. If we go to double check this, on the outside we've got x times negative 5, which is negative 5x. On the inside we've got 2 times x, which is positive 2x. Negative 5x plus 2x is negative 3x. Is that what we wanted? Not quite. We wanted positive 3x. But since it's the opposite of what we wanted, it gives us a clue as to what needs to be changed. It means that instead of positive 2 and negative 5, what we need is negative 2 and positive 5. We had the right number, just the wrong sign, so let's switch the signs. Now on the outside we have x times 5, which is 5x. On the inside we have negative 2 times x, which is negative 2x. That adds up. 5x plus negative 2x makes 3x, and that is what we wanted. In your notes, I want you to try to factor this one. X squared minus 9x plus 20. See what you come up with. So we see that there are no common factors. So we're going to try to do this reverse multiplication. The first terms, again, have to be x and x. The last two terms have to multiply to make 20. So we have 1 times 20, 2 times 10, or 4 times 5. Which one do you want to try? Let's do the 4 times 5. So positive 4, positive 5. If we test this, on the outside we have x times 5, which is 5x. On the inside, 4 times x, which is positive 4x. That adds up to make 9x. Is that what we want? No, we want negative 9x, not positive 9x. But again, we have the right number, just the opposite, the wrong sign. Well, this is a positive 20, but to multiply to make a positive 20, we could have positive 4 times positive 5, or we could have had negative 4 times negative 5. Let's try that. Make that a negative 5 and a negative 4. Now on the outside, x times negative 5 is negative 5x. And on the inside, negative 4 times x is negative 4x. And that adds up to make negative 9x, which is what we wanted. So those negatives can affect us in a couple of different ways. Let's have you try this one in your notes. X squared minus 11x minus 12. I'll give you a minute for that. So, is there a common factor here at all? No. So it's 3 terms, trinomial, so we're going to try to do that reverse multiplication. Of course, it's still x times x to make x squared. This is a negative 12, which tells us we have to have one positive and one negative. So either negative 1 times 12 or 1 times negative 12. Negative 2 times 6 or 2 times negative 6. Negative 3 times 4 or 3 times negative 4. Which one do you want to try? Negative 1 times 12? No, which one? The 1 times negative 12. Okay, so positive 1 and negative 12, minus 12. If we double check that on the outside, we do have x times negative 12 is negative 12x. And on the inside, 1 times x is 1x. What does that add up to make? Negative 11x, which is what we needed for that middle term. So that is correct. X plus 1 times x minus 12. All of the ones we've seen so far, the x squared term has had a coefficient of 1. So it's just been x squared. But again, that's not always the case. So here we have a coefficient of 2 on that x squared to make 2x squared. So what are we going to do? Look for a common factor. Do we have one? Yeah, every number there is divisible by 2. Is the variable part of the common factor? No, because there's no variable in that third term. But we can divide out that 2. 2x squared divided by 2 is just x squared. 14x divided by 2 is 7x. 24 divided by 2 is positive 12. Now, before we finish, we have to look to see if we can still factor. We've taken out the greatest common factor, the 2, but this can be split up more. Just like if we had 12 when we factored it, we might have said it divides by 3 and what's left over is 4. Well, that 3 can be split into 2 times 2. It can be split into more factors. Same here. This can be split up using reverse multiplication. Those first terms, since that's just x squared, of course, will be x and x. What are the last terms going to be? Plus 3 and plus 4. They have to multiply to make 12. Let's double check to make sure that gives us the 7. On the outside, x times 4 is 4x. On the inside, 3 times x is 3x. That does add up to 7x. That's what we needed there. Is this our answer? Yeah, just like over here, we still needed to put the 3 with them. We still need to bring that 2 down. So this is 2 times x plus 3 times x plus 4 is the factoring. It won't always be that the greatest common factor brings that x squared down to having no coefficient. We may have to deal with that x squared having a coefficient, like 2x squared plus 5x plus 3. Is there a common factor there? No. No common factor. It is a trinomial, so we're going to try to do reverse multiplication. Now, however, these first 2 terms have to multiply to make 2x squared. So instead of just x times x, one of them has to be 2x. Now this one I made pretty easy. The last two terms have to multiply to make 3, so that's just 1 times 3 or 3 times 1, right? If I try 1 times 3, on the outside, 2x times 3 is 6x. On the inside, 1 times x is 1x. 6x plus 1x is 7x. Not what I need, is it? Unlike before, when I had to just go to different numbers or change signs when that didn't work out, here, because it's not x and x, it's 2x and x, the order that I put these in matters. So 1 and 3 didn't work. We're going to try 3 and 1. Now on the outside, 2x times 1 is 2x. On the inside, 3 times x is 3x. That adds up to 5x. Any questions? Funny you should ask. Let's make it worse. So let's look at this one here. What would our first step be? Common factor. Do we have one? I heard somebody say it there. They can all be divided by 5. So if I divide out that 5, what will be left? Four x squared minus 47x minus 12. Good. Well, now what should we do? Yeah, there's no common factor there, but let's see if we can do FOIL in reverse. So these first two terms have to multiply to make 4x squared. What should we use? 2x times 2x, or it could be 4x times just 1x, right? How do we know? Well, we try it and see if it works. These last two terms have to multiply to make negative 12. So it's a negative 1 times positive 12, 1 times negative 12, negative 2 times 6, 2 times negative 6, negative 3 times 4, or 3 times negative 4. Which one do you want to try? I can hear the wheels turning. You're trying them all. None of them are working well, are they? The closest one that gives us, if we use the negative 12 and a positive 1, if I try that, 2x times 1 is 2x. Negative 12 times 2x is a negative 24x. That gives us a negative 22x. That's nowhere near the negative 47 we need, is it? If I try any of these other combinations, none of them get any closer. That doesn't mean it can't be factored. It means we tried the wrong option to begin with. Instead of 2x times x, it's 4x times, or 2x times 2x, it's 4x times 1x, or just 4x times x. Now one of these combinations over here will work. Positive 1 and negative 12. Good. Now we do 4x times negative 12 is negative 48x. On the inside, 1 times x is a positive 1x. Negative 48 plus 1 is a negative 47x. That's exactly what we wanted. And of course, we have to remember to do what? Bring the 5 down. So there it is. 5 times 4x plus 1 times x minus 12. So yeah, it can get worse. What do you think so far? Still better than a sharp stick in the eye?
Yeah.
Okay. Now we had that grouping that we did. And when we did these groupings, we factored the first one and then the second one. And of course, here, what would our common factor be for those first two? 2x squared. Perfect. Now it would leave us with 3x minus 7. Good. For the second set, our common factor would be 5. If we divide out a 5, though, we get negative 3x plus 7. What does that tell us? Yeah. We're going to go back and divide out a negative 5. So it used to be a positive 3x minus 7. So that we end up with that same term in here. And then we factor that out. You get 3x minus 7 times 2x squared minus 5. We could have something like this. If I go to factor this, I can use that grouping. There is no common factor throughout the whole thing. For the x squared plus 3, I can factor out what? Just x. I divide that out, I got x plus 3. 4x plus 12, I can divide out 2 or 4, right? Which would leave me with x plus 3. So that is x plus 3 times x plus 4. However, if we look at what we started with here, we realize we got 3x and 4x there. Those could have been combined to make one term. X squared plus 7x plus 12. It really was a trinomial, not a 4-term polynomial. This one we could have factored using this reverse multiplication we've been using. X times x makes x squared. 3 times 4 makes the 12. X plus 3, x plus 4. Exactly what we got there. The reason I'm showing this to you is sometimes we see these trinomials like this, and for some people it is easier, rather than trying to do this reverse multiplication, for some people it's easier to split that middle term like this and use that grouping. So let's say I've got x squared plus 9x plus 20. So the x squared is going to stay up here, and the 20 is going to stay back here. That 9x needs to get split up. What I need to split it up into are terms that are going to multiply to make 20, since this is just x squared. 4x and 5x. We'll do that. The key is the number that goes here, if I divide 20 by it, should give me this number. Oops, come on now. Erase. There we go. So now if I do grouping, both of these divide by x, which gives me x times x plus 4. Both of these divide by 5. Give me 5 times x plus 4. Which gives me the x plus 4 times x plus 5, which is what we would have got doing reverse multiplication. Now, just a thought, what if we put these in the different order? Would that still work? Yeah, if I group this still divides by x, x times x plus 5. This now would divide by 4. 4 times x plus 5. Well, guess what? We still get the same thing in here, and we still get the same factors, x plus 5 times x plus 4. We just have them in a different order. So this factoring is just, in many cases, it's an exercise in exhaustion. You know, that example I showed you of 4x squared minus 47x minus 12. We could have tried a lot of combinations of 2x times 2x before we realized none of them were going to work and had to go back to 4x times 1x. Okay, we're down to just a minute left here, so we are looking at homework 7B, deals with the stuff we talked about today. Also, make sure you're looking at that study sheet coming up. We're looking at, was it 2 weeks after spring break? We have our next exam coming up. Now, we have tomorrow, and then we have one more week before we have spring break. Anybody have any questions? Okay, well, you guys have a great day. We'll see you all tomorrow.